Alright, so we're going to start this one by drawing a simple diagram of what's going on. We have a stone being thrown from the top of a tall building. The initial velocity here, V0, we're told makes it 22-degree angle. Oops, it's above the horizontal. Sorry. Okay. And presumably follows some kind of trajectory like this, and then hits the ground over here. Okay, and we want to know the y displacement from start to finish, right? We don't really care about the y displacement from here to here. It's not a max height problem necessarily, not this part. We want to know the height of the building. That means delta y from start to finish. Okay. Then it says when the stone reaches its maximum height above the ground, so when it's up here, what is the magnitude and direction of its velocity? And what is the magnitude and direction of its velocity the instant before it hits the ground? So we want to know what's the velocity here, and the velocity at the ground, and we want to know how tall the building is. Alright. Well, I'm going to look at the entire motion, not just the part where it goes up to max height, and I'll explain why here in a second. Looking at the entire motion, I'm going to write down what I know for the x and y components. If you haven't done this already, then you should pause the video and work through the problem as far as you can. Okay, so let's see, in the x direction, I got no idea what the displacement is. I know that, as far as the initial velocity is concerned, I've got the initial speed is 7.5, and so that's going to break down into an x component, which is 7.5 cosine 22, and a y component, which is 7.5 sine 22. My sign convention for this problem will be that up is positive and to the right is positive. And the stone is in free fall throughout the problem, so my acceleration is 9.8 meters per second squared directed downward. Alright, so let's see. So V0x is 7.5 cosine 22, which is 6.95 meters per second. My x acceleration is 0, so my final x velocity is 6.95. Time is unknown. The total time of flight is unknown. Delta y, I'm looking for that. I don't know what that is. I know V0 y is 7.5 sine 22. That's V0 y. That's 2.81. The final y velocity down here, right? This is Vy and Vx down here. I don't know what the final y velocity is. And I know the acceleration is minus 9.8 meters per second squared, right? Because it's in free fall, so the the x component of the acceleration is 0, the y component is 9.8 meters per second squared, directed downward. And since up is positive, down is negative, so my acceleration has to be negative. Right? I guess actually we do know the time. We know that the time is 4.6 seconds, right? We're given that information. Good thing, or we'd be stuck. Okay, so let's start with part A. It asks us to find the height of the building, find delta y. Well, that should be easy enough. We can just use the equation that doesn't have Vy in it, and that is delta y is equal to V0 yt plus 1/2 at squared. So that's 2.81 times 4.6 plus 1/2 times minus 4.9 times 4.6 squared, which works out to be minus 90.76. Right? So that's the y displacement. It's negative. That makes sense because remember displacement is a vector and the displacement points down from start to finish. And it's negative. So the height of the building then is the height is just the magnitude of that displacement rounded to two significant figures, so that's 91 meters. Alright, part B asks, it says when the stone reaches its maximum height above the ground, what is the magnitude and direction of its velocity? Well, I don't really have to do anything here. This is all in the assumptions, right? I know that throughout the motion, that Vx is equal to 6.95 at max height. Right? Vx is 6.95 every point along the motion. Vx is equal to 6.95. I also know that Vy is 0 at max height. Right? Remember, that's one of those basic assumptions that we make. And so there's our two components right there. And so the velocity is equal to 6.95. Well, I need to round that off, don't I? It's 7.0 meters per second in the plus x direction. Right? So I really didn't have to do any calculations for that part. All right, then part C asks for the magnitude and direction of the final velocity the instant before it hits the ground. And of course, the x component is still 6.95 just before it hits the ground. And to find the y component, I go back up to my y assumptions and use the equation that doesn't have delta y in it, and that is Vy is equal to V naught y plus AT. Okay, so Vy is equal to 2.81 plus negative 9.8 times 4.6, which is negative 42.27. Okay, so now I can make a little triangle here, my x component and my y component. Okay, the x component of the final velocity is 6.95. The y component is 42.27, pointing down. Okay, so that triangle has a magnitude, has a hypotenuse of v there. That's the magnitude of the speed, magnitude of velocity, and it's going to have an angle theta. So the magnitude of the final velocity is the square root of vx squared plus vy squared, which rounds off to 43 meters per second. And theta is inverse tangent 42.27 divided by 6.95. Remember, I don't make any of these numbers negative when I'm solving a triangle. I just use all positive values. And it's 81 degrees below plus x because that's what my diagram indicates. Right, that it's below plus x. This is the plus x direction here, and we're below that. And below, the word below, that's where the negative sign comes in, right? Okay, so I'm done.